Hey everybody, this is KSL Shashank of BTech second year Mechanical Engineering regular. My roll number is 23011A03008. Our sir is G. Raju sir from Triple E department. He's an assistant professor and today I'm going to discuss about earthing and different types of batteries. So what exactly is earthing? Is also called grounding. It is a crucial safety mechanism in electrical systems. It involves connecting an electrical system to ground using a low resistance conductor. Let's see it. As I mentioned here, the process consists of connecting some specific areas of an electrical power system through low resistance wire for safety purposes. As this wire conducts the electricity, this electricity is dissipated into the ground, and this process we call it as earthing. The main purpose of earthing is to provide a safe path for these fault currents or excessive currents to dissipate into the earth, thereby preventing electrical shocks and protecting equipment from damage or voltage spikes or surges. There are different types of earthing, each suited for different environmental conditions. The most common methods include pipe earthing, plate earthing, strip earthing, and rod earthing. Let's discuss each of these types in detail. So, what is pipe earthing? Pipe earthing is one of the most commonly used methods. In this method, we are going to take a galvanized steel and place it in underground. This pipe is generally 2 to 3 meters long and it is vertically buried into the ground. This setup allows these excessive currents, or what we call the faulty currents, to be safely discharged into the earth or the soil. This method is highly affordable and it requires a very much low maintenance. So, and its depth, the depth that I've mentioned, that it is of 2.5 to 3 meters, it usually depends on the type of soil or the condition of the soil. The second type of earthing is plate earthing. In this type of earthing, a metal plate, either galvanized iron or a copper plate, is used to connect all the electrical conductors to the earth. The plate is placed at a depth more than 3 meters or 10 meters from the ground, and it is connected to electrical conductors that transmit fault currents safely into the earth. The diameter may vary from 12.5 millimeters to 19 mm in diameter, and it should not be placed more than 3 meters or 10 feet from the ground. This method provides a large surface area for grounding, and it makes it and making it effective in dissipating electrical surges. However, it 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 requires regular corrosion over the time. Plate earthing is we commonly use it in power stations and industrial plants and in other large electrical installations. It is This method is somewhat costly and requires more maintenance as compared to pipe earthing. The third type is strip earthing. It involves the use of a long metallic strip. As you can see here, this metallic strip, it consists of two pipes, inner pipe and outer pipe. Has less diameter as compared to the outer pipe, which usually is of 6 mm diameter, and it is placed at a depth of 0.5 meters horizontally. This strip provides a continuous low resistance path for fault currents. That is how the earthing takes place with this method. And the last type is rod earthing, also called as ground rod earthing, which we commonly see in our households. It consists of driving a copper galvanized steel rod dip, which is covered, which is placed over the copper rod and is driven into the ground. It comes in inside we have galvanized steel which is covered by the copper rod and it is placed into the ground. This pipes helps prevent the copper rod from corrosion. Copper has anti-corrosive properties, and also it increases the surface area of the electrode, which improves the overall conductivity. So when the current passes, it dissipates into the ground, therefore providing the earthing. The depth is usually around 2 to 3 meters, depending on the soil condition. This method is highly effective in rocky or dry soils where other earthing methods may not work well. Where other earthing methods are quite difficult, we use this kind of earthing. So that's why we commonly use it in our residential buildings, telecom towers and substations, etc. So why do we need earthing? What is the necessity of earthing? Let's discuss. It prevents electrical shocks. It protects electrical equipment, and it prevents the damages that takes place on the machines due to overload or in other cases the short circuit conditions. It also reduces the risk of fire and fire hazards caused by the electric or leakage currents. It maintains the voltage in stable condition and prevents fluctuations in the electrical systems. It also ensures safety and matches all the safety regulations for electrical installations in our homes. So our next topic is batteries and their types. So what's a battery? What exactly is a battery? Batteries are the electrochemical power sources which convert chemical energy into electrical energy. They are used in everything from our small household electronics to large industrial power backup systems. These are generally of two types, primary and secondary. Let's discuss both of them. Primary batteries are also called non-rechargeable batteries. These are the electrochemical cells that convert the chemical energy into electrical energy and discard it after use. That means that they are used once and after that they cannot be used again. That's why they are called single-use applications or non-rechargeable battery. The main principle of primary batteries are based on the electrochemical reactions that takes place at the cathode and anode. As you can see here, we have taken the example of a zinc carbon battery. At anode, oxidation takes place, and at cathode, the reduction takes place. And you can see the overall reaction here. The electrical current is generated, and once all these reactants that we see here are consumed, the battery stops functioning. And all these reactions are irreversible, which indicates that these batteries are used for one time, single use purpose. So let's look at different types of primary batteries. We have alkaline battery, which we use in remote controls, zinc battery, which we use in low power devices, lithium battery, which we usually find in camera and other devices, silver oxide batteries in watches and calculators, and finally mercury battery, also called obsolete, which we use in medical instruments and other military applications. You can see the images of primary batteries and the functioning of a primary battery. It is provided with a positive terminal as well as a negative terminal, and we can see here the electrodes, two zinc electrodes. Let's move on to the second type of batteries, which is secondary batteries. By definition, we can already say that these are called the rechargeable batteries. Unlike the primary batteries, which are used for one time, these batteries can return to their original state after being discharged by applying an electric current in opposite direction. That means that we can use these batteries multiple times because the reactions that we have seen in here, they get reversed, which indicates that they can be used again and again. And how they are used? They are used by passing the electric current in opposite direction. What is the principle of these batteries? That during discharge, the chemical energy in the battery is converted into electrical energy with the help of these electrochemical reactions, as you can see here. When charging, an external electrical energy sources forces the reaction to reverse, restoring the original chemical composition of the electrodes. You can see here the secondary battery and its structure, the composition of a secondary cell. The recharging process involves applying an external current to restore the original chemical composition of the electrodes. This makes these batteries more cost effective and environmental friendly as these reactions are reversible as compared to primary batteries. Let's look at two different types of secondary batteries. The first type is lead acid battery, which we use in cars. It consists of lead dioxide and lead along with H2SO4 as electrode. The second type is nickel cadmium battery, which you use in cameras and other medical devices, and it consists of nickel oxide hydroxide as positive electrode, cadmium as a negative electrode, and KOH as the electrolyte, potassium hydroxide. Third type is nickel metal hydride NiMH battery. These are we mainly see these batteries in HEVs, also called as hybrid electric vehicles, and in digital cameras, providing better energy efficiency. The principle is similar to nickel cadmium battery, but the difference is instead of cadmium, we are using hydrogen absorbing alloy instead of cadmium. The fourth type is lithium ion battery. These batteries we commonly see in our smartphones and in laptops and also in electric vehicles. It consists of lithium cobalt oxide in the positive electrode and graphite at negative electrode, and lithium salt acts as the organic solvents, or what we call the electrolyte. It is made up of these lithium salts. So the last type is sodium ion battery. This sodium ion battery is nothing but the extension of lithium ion batteries, just that we are replacing lithium with sodium here. The main usage of these batteries are to produce current, to generate current, to generate electrical energy at a larger scale or at large scale storage locations. So let's compare primary and secondary batteries. Primary, as we have seen earlier, primary cells are irreversible, which means that once they get discharged, they cannot be charged again. But in case of secondary cells, as the reactions are irreversible, which is mentioned in the last point, they can be charged easily by passing the current in opposite direction. That's why they are called reversible cells. The internal resistance of these primary cells is high, whereas the secondary cell is very low. They are comparatively cheaper and secondary cells are comparatively expensive. Size also matters here in case of batteries, where primary cells are at smaller size and secondary cells are at larger size. These primary cells are very much portable, whereas secondary cells are used in larger appliances such as inverters and automobiles, etc. So, what are the applications of these batteries? Why do we need batteries? Batteries are an integral part of our modern life, provide a vast range of devices. The differences between secondary batteries helps in selecting the best energy solution for specific needs. We have seen the differences between primary and secondary, and we know when to use primary and when to use secondary. So the applications also follow their route. As you can see, the primary application is for consumer electronics. Primary batteries power low drain devices like remote controls, and secondary batteries are used for much higher appliances where the application is at a larger scale. And the second one is electric vehicles. Nowadays we see too many electric vehicles. This is because of the usage of lithium ion batteries which power these electric vehicles, and they serve as backup power for sensors and other emergency systems. We also get to see the applications of batteries in many other fields like medical field and in military as well, where we use secondary batteries and also primary batteries in devices requiring single power, and in secondary batteries where the application is very large or at a larger scale. So to conclude, each of each of these batteries have their applications at various fields based on their requirement. So thanks for your time. Thank you.